So I'm going to start with filling in our zeros, or like the quarters that we've done several times, that we have 0 degrees here or 0 radians. And that's what this is. The little line with the dot, that's our degrees. The little line next to it is our radians. So all the way over here, we know that one, that's 180 degrees. That's our straight angle. Also known as pi radians.
At this time, juniors report to the auditorium. Junior teachers report to the auditorium. Thank you.
Have fun at your meeting. I will get the video posted as soon as I can at the end of the period. All right, we've also talked about our 90 degrees before, where this one's our 90 degrees and this is our pi over 2. Oh, that's why that's so chunky. I'm using the wrong pen. I'm like, why is this not fitting on the lines? Oh, it's still not fitting on the lines, but that's okay. Pi over 2. And then at the very bottom, we've done that one as well before. That was our 270 degrees. And our 3 pi over 2, right? So those are all pieces we have filled in before as we were sketching and drawing things before. So the piece that I think is easiest to fill in first is if we look at it, we go, all right, so I've got 0 and 90. Let's get that halfway point. What is halfway between 0 and 90? 45. So I'm going to do this in green. 45. What is that in radians? What's halfway between 0 and pi over 2? Pi over 4. So what we're really doing is we're counting by pi over 4. So 0, pi over 4, 2 pi over 4, 3 pi over 4. So I'm counting by pi over 4. To fill in these quarters. 4 pi over 4 simplifies to 1. 5 pi over 4, and I'm just going to work around the circle. Down here, this one would be 6 pi over 4, just simplified. 7 pi over 4. We're going to do the same thing with the degrees, filling them in, counting by 45s. 0, 45. Plus 45 is 90. Plus 45, 135. Plus 45 gets you to 180. Plus 45, 225. Plus 45 gets you to 270. Plus 45, 315. Okay? So that's looking at this halfway point. There's a lot of other things in here, but that gets you that line that's right in the middle of each of those quadrants. And then what we have here is we're like, well, they're not all equal pieces, so I know it's not halfway between the 45. But these are all dividing, like this piece is the same size as that piece. This piece is the same size as that piece. So what we have here is this piece divides it into thirds. This piece divides that third in half. So what we really have is the rest of the blanks are all counting by sixths, which is the most impossible word to say repeatedly, and I'm going to have to say it about 30 times now in this next thing. So what we're going to do is we're going to count up by sixths in our radians. So this is our very first one, and it's pi over 6. Our next blank is 2 pi over 6. What does that simplify down to? 1/3. So, or pi over 3, right? Or 2 pi over 6. I don't really care, but I prefer pi over 3. So then it's 3 pi over 6, which would simplify down to pi over 2. So we're back here. 4 pi over 6, also known as 2 pi over 3. Yep, there we go. Starting to see some patterns here. 5/6 pi, 5 pi over 6. And we're at 6 pi over 6, which is 1. Means we're in the right space. It gives us a few like checkpoints as we go through it. So then we're going to keep going by 6. 7 pi over 6. The next one is 8 pi over 6, or 4 pi over 3, or 4/3 pi, however your brain works it. Nine pi over 6. Again, same thing as 3 pi over 2. So we've hit our next checkpoint. Yeah, so that's 10. So it's 5 over 3. Yep, 5/3. And 1 left on the radians. Oh my gosh, we're almost there. And that is 11 pi over 6. That is not the right thing. There we go. Our last piece to fill in today is our degrees, which means we need to figure out what these degrees are so we can figure out what we're counting by. They're 30 and 60. You're exactly right, Tommy. So you can think of it as, remember we thought of this as being 1/3 of our whole thing. I didn't even touch the screen, Grumpy. Oh my gosh. Okay, so it is counting by 30s. So our degrees, whenever we're filling in these lines, is counting by 30s. So this one's 30. This one's 60. And we're at 90. So counting by 30s. So the next one is 120. Next one is 150. Next one is 180. And we've hit another checkpoint. Yay, we're on track. I was like 210. 240. 270. Yay, checkpoint. 300. 330. And then 360, which is the same as 0. Yay, checkpoint. So our 0, 90, 180, 270, those ones we're like locked in on. They provide excellent checkpoints for us to kind of double check that we're going around there. And like I said, there are multiple different ways of filling this in. You'll wind up with the same stuff in the same spots. There are some people who just do this first quarter and then do some like reflections to fill this in. There's like, or just like adding 90s or whatever. So there's lots of different ways. So if you did not like that or it felt awkward and weird, a lot awkward and weird, not just a little awkward and weird, check on YouTube for like search unit circle. And there are 50 million videos. Okay, so for now, that's what we're filling in. This is, again, once we fill in what these ordered pairs are, we'll start doing those timed quizzes on it. We're not doing the ordered pairs quite yet. That might be a Tuesday thing. Okay, or it'll be sometime next week. But we wanted to kind of get this to you so you could start seeing it, start looking at it. It looks super complicated and it looks super detailed. It is patterns. It is just patterns. Okie dokie. I need more time on this page, because we're going to move on and do some other things related. They don't feel related, but I promise they are. Okay, because we're going to start section 6.2 today, which is all about trig functions, which you have seen before. This is what we're going to be doing a lot this semester. We're going to be dealing with trig identities and trig functions. So this is when we're thinking about a triangle. It's always about a right triangle. So I'm going to give us a little sketchy triangle up here. We're always thinking about a right triangle. And the angle that we're talking about is any of the ones that's not the right angle. It doesn't matter which one. Well, it'll be labeled. So I've picked this one because it makes absolutely no difference. But sine of theta, the way we calculate that is where we're thinking about our opposite side, our adjacent side, and our hypotenuse. Remember those ones? Is that vaguely familiar? SOHCAHTOA. Boo, I just finished my coffee. Oh well. So yeah, it's our SOHCAHTOA where sine is our, what is it? Opposite over hypotenuse. Cosine is adjacent over the hypotenuse. And tangent is our opposite over adjacent. For our sine, cosine, and tangent. How about for cosecant? This one. Because that one doesn't come with a handy rhyme. Do you remember that one? Cosecant is related to sine, but it's flipped. It's the reciprocal of sine. So cosecant is actually hypotenuse over opposite. Just like sine and cosecant are related, cosine and secant are related. So they're upside down again. So we've got our hypotenuse over adjacent. And tangent and cotangent are again related. We have our adjacent over opposite. Questions on any of those pieces as they are? It's always related to where our theta is, which angle we're talking about. The adjacent is the side touching. It didn't touch the screen. And the opposite is the side it faces. All right, so what it means by reciprocal identities at the bottom is the relationships across this way. So that sine is, the reciprocal of sine is cosecant. So sine of theta is 1 over cosecant theta. Or you can think of it as 1 over sine. I gotta work on not doing it in cursive. Is the same thing as cosecant. They're reciprocals of each other. Sine and cosecant, cosine and secant, tangent and cotangent. A way to remember, because the biggest mistake we have is that we'll flip these two in our head. Each pair only has one co. So cosine won't go with cosecant. There's only one co in each pair. So then we have cosine goes with secant. Or 1 over cosine is the same thing as secant. I have a bad habit of not saying the theta. All of those have a theta. Cosine of theta and 1 over secant theta. 1 over cosine theta is the same thing as secant theta. They are reciprocals of each other. They're all related. They just look at our angles from a slightly different perspective. And our last one is that, I gotta stop writing in cursive. Tangent theta is the inverse or the reciprocal of cotangent theta. 1 over cotangent is this, I totally just did that backwards because I wrote the exact same thing. There we go. 1 over tangent is the same thing as cotangent. So we are going to be working with these trig identities a bunch of cruncha. Like all semester. Like we're going to be working with these guys a lot. Lot. This is the focus of the semester is trig. And that's what these are. These are the trig functions and their basis. Like, yeah. We have trig functions through a lot of stuff. Okay, so it's really important that we have these down. The unit circle and these trig functions you're gonna need. I'm only, at least thus far in this chapter, I'm only gonna give you like one more table of stuff to memorize, but this one has a lot more memorization than first semester did. Because you need to know these and you need to be able to like, we're not gonna do a time test on these, but we're gonna work with them a bunch. You'll get them eventually, but we're gonna, just because we're gonna work with them a lot. Okay, so we're going to start with evaluating some of these and using them, and we're going to find all 6 trig functions given some information. Okay, I don't see any more people writing, so I'm going to go on to the next page. So if I tell you cosine of theta is 3/4, we're going to find everything else. It's always going to be a right triangle. Because that's how we do trig functions. Trig functions always do with a right triangle. So whenever we're kind of evaluating like this, I'm always going to draw a triangle. And I'm going to pick an angle to be my theta so that we can label things out. It's in my pocket. There we go. I found it. Look at me tricking myself. So cosine, if we remember from that section we just wrote, English is good for me. Cosine theta is made up of our adjacent over hypotenuse, right? So if I've picked this to be my theta, that means I know that this side is 3 and this side is 4. That's what it means. Adjacent over hypotenuse, 3 over 4. What can I do to figure out this side? Pythagorean theorem. A squared plus b squared equals c squared, with a and b being the two legs, and c squared, or c is our hypotenuse. So you can give it a letter, you can put a question mark. I'm going to put an x just because I like that variable. You can put a b, you can put an a, it doesn't matter what you call it. But what we know is that 3 squared plus x squared equals 4 squared. Pythagorean theorem. So let's find out what x is. Three squared is 9, plus x squared equals 16. What does x squared equal? 7. So what does x equal? Square root of 7. And we're going to leave it as square root of 7. And we're not going to get a decimal for it. We're just going to write it as square root of 7. So I can come up here and instead of the x, I can write square root of 7. I'm just going to cross out the x, so not with purple though. Just so it's still there for people who are looking at the notes without watching the video. Okay, so now I know the dimensions of all the sides. So what we're going to do is we're going to find all 6 trig functions by plugging in those values. So sine, I got to do it in print. Sine of theta opposite over opposite over hypotenuse. So what is the measurement of the opposite side? Square root of 7. What's the measure of our hypotenuse? 4. So sine of theta is square root of 7 over 4. Okay. Cosine, we actually know it's the one they gave us. It was 3 over 4. Tangent. Square root of 7 over adjacent over 3. Not too bad, not too bad. Oof. So those are the ones we're the most familiar with. We've worked with those a gazillion times. Then let's do our other ones, our more rare functions. They're like special shiny Pokemon. So let's do our cosecant. And you have a couple of ways of doing it. You can either go back and grab our definition where we're talking about it being hypotenuse over opposite. Or we can remember that cosecant is the reciprocal of sine. So it is 4 over square root of 7. And if we were still in algebra 2, that would be a totally acceptable answer. But we rationalize our denominators here. So what do I need to do to get the square root out of my denominator? Multiply by square root of 7 over square root of 7. So that we don't have any radicals in our denominator. So I'm multiplying it by 1. It's just a really weird looking 1. because that makes my denominator be the square root of 7 squared, also known as 7, right? So our numerator is 4 square root of 7. So we do need to rationalize our denominators. Whenever we see a radical in the denominator, we got to fix it. And that's going to happen a ton. A ton. Okay, so we're going to do the same thing with our secant. We did cosecant, let's do secant. Secant theta, remember that's the reciprocal of cosine. So it's going to be 4 over 3. Again, you can also do that by going back to our definition of secant, being hypotenuse over adjacent. Cotangent is the reciprocal of tangent. So 3 over the square root of 7. Uh-oh, radical in the denominator. We gotta fix it. So we multiply by a funny looking 1. Square root of 7 over square root of 7. So we have 3 square root of 7 over 7. Okay. So you found all 6 trig functions. Yay! I don't know why my voice went all squeaky on that one. I'm like rocking a baritone today. I don't know what's going on. Okay. We're going to do this again. To practice this again. We're in really good shape, like time-wise. Like, I am okay with where we are. I'm super okay with where we are. Cool. Because I want to get us. We're in such good shape. Okay, let's do another one. Same vibe. We're going to find all 6 trig functions given the tangent this time. Again, I've drawn myself a triangle. I picked a different angle just because it's good for us to not always have to have the one angle. If you always use the bottom right angle, that's totally fine. I try and make it so that we don't have to use the same one every time. Gives us a little flexibility. But we're going to fill in our values just like we did on the last one. We're going to remember that tangent, when we define that, that's our opposite over adjacent. So when we're looking at our triangle sketch, whichever angle we've picked, our adjacent side is the 7, and our opposite side is that 24. And it genuinely does not matter if your triangle is to scale or even to scale-ish. It is just, so even if you drew like a really small side for that 24, it does not matter. It'll give us the same values. Follow your numbers. Okay, so we do need to find our hypotenuse's dimension so that we can do all of our trig functions. So this one I'm going to label it C. Because I know my A, I know my B, we got to find our C. Pythagorean theorem again. And this is one of those ones when we're so thankful to be able to use calculators because 24 squared, what? Trying to do that by hand. So we wind up with 7 squared plus 24 squared. Why did I do that in black? That was a strange choice. There we go. Plus 24 squared equals C squared. And I cannot help but think of the Lego Batman movie whenever we do Pythagorean theorem. It's fantastic. So we're going to multiply these out. 7 squared is 49. That one we should know off the top of our head. 24 squared we will not know off the top of our head. But luckily we can use our very bestest friend, the calculator. And we get what? It's like you're a step ahead of me. 576 equals c squared. Add those together and we get 625. I already heard you see that one. So what does c equal? That one's a perfect square, so c equals 25. So we know that c actually equals 25. So let's fill in all of our trig functions. We're going to do sine of theta. What's our sine going to be? 24 over 25. What is cosine of theta? 7 over 25. What is tangent of theta? Say it louder. 24 over 7. Sometimes y'all gotta remember I'm old. I'm literally twice your age. More than. All right, so then let's fill in our other ones. We've got our cosecant. That goes with sine because there's only one co in each pair. What's cosecant? 25 over 24. How about secant? 25 over 7. And cotangent. Boom. And you know what? I think I'm going to stop right there. Okay, so you guys have 5 minutes. Oh my gosh, I'm stopping before the end of the period. What? Because the next one is not bad, but it's a little annoying and finicky. And so we'll just do that one tomorrow. It also puts us really nicely into starting into the figuring out what those ordered pairs are going to be. Oh, snap. So I'm going to put up our thingy. Gotta get to that page. Boom. All right. So I think you guys can do up through, I want to say it's 15 or 17. I know 21 and 25 are what we're going to be doing tomorrow, hopefully. All right, so we'll get through what we get through, and that's going to be it, but I just did not feel like trying to squish that one in.